All right, in the previous exercise, we did our basic project setup and we created a simple hello world HTML file, largely to simply be able to test access to our project contents via a web browser. Everything's working fine. So now we're ready to start on our project really at its core. And before we can begin creating services and user interfaces and all these sort of things, we really need a data model. We need basic database schema. We need tables within that schema. We need other types of database artifacts. So, of course, we could, like any database, we could go over and we could use standard SQL and we could say create table and issue the SQL statements to create the table with the particular columns and various data types. And that's fully supported on SAP HANA. But then you don't really have a good mechanism to be able to transport that short of saving SQL files and re-executing them on another system. And you don't have a design time version of that catalog runtime object. And with SAP HANA, we wanted to have a design time. We wanted to have a form of data dictionary, an abstraction layer that allows you to define your runtime artifacts, but store them in the repository so that they can be transported easily along with all our other development content, and also to allow us over time to introduce other concepts like maybe some sort of extension mechanism, the ability to define tables and views in a higher level metadata representation and then have the runtime objects generated, and maybe they aren't a one-to-one generation. It allows maybe customers to add fields to existing tables and do that in a very safe manner. And we see the beginning of that with these initial runtime design time artifacts. So there's HDB files that can be created for most all of the SQL catalog artifacts. And to begin with, we'll create a schema. So I'm going to use the data package or the data folder in my project just to keep all the low-level catalog database tables and other artifacts together in one package. And I'm going to begin by creating a new file. And I want to create a schema. So this file has to begin. The file name has to be the name of the schema that I want to create. So I want to create a schema named Workshop X and then my group number. So Workshop X underscore 01. And then the file extension has to be HDB schema. And that will tell the system that this is a schema artifact. It should generate a schema when I activate this particular file. So the syntax for the schema is pretty simple. Schema name equals, and then I give it my schema that I want to generate, X, Workshop X underscore 01. Not a whole lot to that. I'll save it. I'll commit it. And then we'll activate it. Now, it activated successfully, no errors. That means there is a new schema already created in the database. The catalog objects are created automatically upon activation, or if I change the artifact, say I add a new column to a table, then the activation process will generate the alter statements necessary to alter the catalog object. Now, I will tell you right now, if I go over to the catalog and I do a refresh, there is my schema. So you can see it already created out there. now that we have our schema, we can begin to create tables within this schema. So let's say new file, and very similar to the format that we used to create the schema, we have a similar artifact called HDB table, and with this we'll give it the name of the table. HDB table is the file extension, so header is the name of the table we want to create, and you don't want to watch me type, so I will cut and paste in. So the syntax is we have to give it a schema name that we want to create this within. So we want to create it within our schema, workshop x01. We'll put it in the column store, give it a simple description. Then we define each of our columns. So we're going to have an order ID, a created by, created at, currency, gross amount. And you can see the basic syntax here where we're defining the data types, the lengths, precision, scale, and we can add comments as well. And then we end with our primary key, which is order ID. I can go ahead and save that. And at the same time, let's go ahead and create an item table. HDB table. Very similar syntax. I'll supply my schema name. Workshop X01. Yes. This is our item table. So we have an order ID, an order item, product ID, quantity, quantity unit, delivery date, and two primary keys, order ID, order item. Simple header item order table combination. At this point we can go ahead and commit both of these files, and we can activate. This will generate the tables. And you'll notice I was able to use such simple table names like header and item, and I don't really have to worry about any sort of conflict because the runtime object, the table itself, gets the entire package hierarchy appended as part of the name of the table. So it actually turns out to be workshop session x01.data : header. So that is the format. We take the package hierarchy with each folder, each package in the hierarchy separated by a dot, and then two colons to separate the package hierarchy from the actual table name. We can see these in the SQL view, although I don't have privileges to them yet. As I've generated these objects, I can see them here, but I don't have access to them yet because they're actually being generated by the repository user ID. I'm not the one who issued the create statements. The activation process created them, so I don't yet have access to them. Once I have access to them, we'll be able to come back here and you'll be able to see all the details, the columns, and the various runtime information. Okay, one more piece to our database layer. We have tables, we have a schema. Now we need some sequences. Sequences are automatically incrementing number ranges that we can use to generate things such as the order ID. So this is very helpful later when we want to insert data into this table. So let's go ahead and set up a sequence by creating a new file named orderid.hdb sequence. And the syntax for our sequence, again, so I'll have fairly similar syntax. We give it the schema that we want this generated within, the starting number in our number range, and then we create a connection between the sequence and our table, and we have to fully supply the table name along with the package, so it's workshop session X group number 1 dot data, and then header. So the sequence will be connected to the header table, at least in the repository, and if you try to delete the table, for instance, you'd get a message that, hey, there's a dependent sequence on this table. So we have this sort of relationship between these objects that would not normally exist at the SQL layer alone. So save, commit, and activate our sequence. And just in case you're curious, we're not to the point yet where we would want to insert, actually perform an insert, but if you are curious about how a sequence is used inside an insert statement, for instance, if we were inserting into our header table, where we would supply values, and the others where we're passing in hard values, in this simple example, this insert example, we can simply reference the sequence that we created and the dot next value on that sequence, and it will automatically increment and insert the next value for us. Always assuring that we have a unique incrementing value for our primary key. Another artifact that we can create at this level with an HDB file is a simple SQL view. So although later we'll learn how to create HANA-specific modeled views like the attribute view and the analytic view, calculation views, and these are done with a different tool, sometimes it's necessary to create simple SQL catalog views. And therefore we have a process that is a file-based artifact, very similar to our tables and our sequences and our schemas, for creating a SQL view. And we'll do the same thing here, file new, and we'll say orders ext.hdb view. And once again, the syntax is fairly similar to what we've seen. I'll cut and paste it in. In this case, we have the schema that we want to generate this in. So same as all our other artifacts. And then the query is the SQL statement itself that would be the select for the join condition. Now I'll give you a little hint. One nice way to do this is if you want a slightly simpler tool to do this, you can say new view in the navigator tool, and then there's a bit of a graphical tool, and probably tell me I don't have, here, I can add the header and item and create my join condition on these and my join type and so forth. And when I get done with this, I can see the SQL that would be generated by this. I've got to add some columns here. And once I have some columns, then I could see the actual. I got to give it a name. And then I could execute this. I would actually be able to see the generated SQL statement. You could cut and paste that SQL statement and then put it in here. One thing you do have to remember to do, because this is JSON notation, all the quote marks around the columns that are part of your SQL statement do have to be escaped. That's why you see the backslash in front of all of the quote marks. That is the escaping, so it's safely encoded inside the JSON format. We do have to, in the case of my template here, we're just doing select. listing the fields from our schema. Put both those in, and then workshop session X group number 01 from the header table joined left outer join to the item table with an order by, and then we have to create this depends on. Once again, this is so that the repository knows that this view is dependent upon these two underlying tables. It creates a link, a relationship in the repository that can be checked at runtime, activation, deletion, those sort of things. So we have, once again, some information about this view and how it relates to the tables that we wouldn't have in simple SQL alone. So I'll go ahead and save my view, commit it, and activate it.